of the time, and I'm pretty sure it'll happen over the next 2 days. That said, I'd like to introduce our first speaker. George, do you want to start coming up? George Hotz is a pretty interesting guy. He had his first 15 minutes of fame, as I understand it, hacking the iPhone as a teenager. Is that right, George? And his, George will correct me if I'm wrong in any of this. And his second 15 minutes of fame when he went into his garage and came out a couple of months later having hacked his car to be self-driving. That set him off on a project that he's still in the middle of, creating an operating system for self-driving, both retrofitting existing cars and for new cars. And that's what he's going to tell us about today. George.
Hey. I didn't click it. I'm good. When I talk, I try to be really concrete with words. If I say anything that doesn't sound concrete, please ask me a question. Last couple months ago, I started working with like formal languages like Cock and Isabel, and everything can be specified rigidly. And I think a lot of definitions for a lot of things are just thrown around, and there is no formal definition of them. And then it's a question what you're really saying. A lot of people can have conversations where two people just talk past each other because they have different definitions of a word. But you know, some disciplines like math have found beautiful ways to solve this by giving things formal definitions. So if I'm informal about anything, I mean, it's obviously an informal talk, but I'm happy to clarify. So when you think of self-driving cars, what's the first company you think of? I hear a few Teslas. I also heard Waymo. I think, yeah, Waymo is probably the one that captures the perhaps national consciousness of what self-driving cars are. Maybe the other one people mention is Uber. Uber actually got the most press about self-driving cars. If you do a Google Trends search for them, it's when Uber killed somebody. But the traditional, maybe this is just because a lot of marketing dollars have been poured into it, the traditional idea of self-driving cars is the Waymo. It's a car with no people in it, and you can call it from an app, and it will drive down your idyllic suburban street, and it will pull up on the curb next to you, and it will flash its little lights and be like, Waymo is waiting for passengers to get on board. You could see this in the Google ads, and it does not reflect the reality of driving at all, if you guys have seen a Waymo ad. Yeah, but you know, so you pull up, oh, look, everyone's so happy they're riding around in a Waymo. Waymo is valued at $175 billion, despite not only not making profit, but I believe not ever making any revenue. So this notion of self-driving cars, maybe distinct from Tesla's, is known as, and we'll get to Tesla, but is known as level 4. Maybe this is the term. The levels don't really mean anything, but that's just the term people use. What it technically means is a car that's capable of full autonomy in restricted areas. So full autonomy in restricted areas, the application people immediately think of is ride sharing. Ride sharing is only a very small % of rides. People who, Google's notorious for this. They don't think about what life is like for most people. Most people don't live in the Bay Area where they can call an Uber and have an Uber arrive in 3 minutes. I'm from suburban New Jersey, very nice area, but you call an Uber, it'll be 20 minutes. So ride sharing is only a very small % of rides. Most people still own cars. And level 4 self-driving is a strictly worse product. So if ride sharing can't even capture these markets, how do people expect self-driving cars to be able to? So first and foremost, anything that's level 4. So also level 4 says something about usually how it's technically done. Waymo uses high-definition maps, a very high precision, like precise to the centimeter, maps of an area. Uses LiDARs that can register every object up to 300 meters away. This is not how humans drive at all. But because of this HD map requirement, they have a smaller surface area. They're also slower. So Waymos travel the speed limit, They come to full stops at stop signs, and they slow down at the slightest hint of hesitation, which maybe if you're trying to design your thing to make sure there's never a PR disaster for your company like Uber, it's the right call. But if I'm sitting there, oh man, I got to get downtown. Oh, Waymo is 18 minutes, Uber's saying 12. I'm going to take an Uber. They're also more expensive. So this might change. This will probably change in the future. Everything eventually gets cheaper. But right now, when you look at a Waymo, those cars cost about $300,000 to $500,000 to retrofit. Again, Google thinks, oh yeah, well we pay all our software engineers $200K a year salaries. Uber drivers ain't making $200K. So they're more expensive. The autonomous vehicle vision wouldn't even be a revolution. At best, it's cheaper ride sharing. A lot of times people get caught up in notions because they see futuristic looking stuff like this and think that this is going to have some revolutionary impact. But they don't think about what the exact same product would be with a human. So all those chatbot AI companies, a quick aside, they're just humans doing the chatting. But they put AI in the name, and they're for some reason, their valuation is way higher. It's a scam. So who's profiting off the scam? This is a company, drive.ai. So they use all their, you read their Medium posts. Oh, they're unbelievable. So we want to make sure that our self-driving car is capable of operating in multiple areas, so we hired engineers all over the world. What does that have anything to do with that? The very, very kind of lofty language. Then when you get down to the root of what they actually made, they made like a neighborhood shuttle bus. You know those like those buses that ride around retirement homes that look like this? And it's not self-driving. There's a human in the driver's seat. They made a $77 million retirement home shuttle bus. What even is the global market for retirement home shuttle buses? I don't know. Anybody consulting with people about the ethics of autonomous vehicles? Oh, well, so if I'm driving down the street and there's a baby in the way, but there's a tree, do I swerve and kill the driver to save the... Has this ever happened to a human? Has this ever been a real scenario? Cars are incredibly dangerous, and 90% of accidents are caused by drivers who are drunk, distracted, or asleep. Not because they swerve to not hit a baby. Yet this captures, again, a conversation about self-driving cars that's completely disproportional to any remote impact it may have, but a lot of people are making money off this, and they're branding themselves as like, well, we're going to consult with the city of Beverly Hills about their autonomous vehicle strat. What? This stuff's not a thing. And then this one. So in the gold rush, so you look at the Cruise acquisition, probably actually a good move for GM. But then it was all the follow-ons to the Cruise acquisition. This was the Delphi spent $450 million for demo quality software that drives around a block with a human in the driver's seat. This was done by Stanford in 2011 in the DARPA Urban Challenge. And even better, they open sourced their code. They paid $450 million, probably for a few engineers and some code that's effectively open source. So what's not a scam? We gotta have the positive. I'm not gonna sit here and rant about all the scammers for an hour. This is car sold in America. Personal vehicle ownership is on the rise and not going anywhere for a long time. Might convert to electric, I think it will. Give it time for the infrastructure to proliferate. But personal vehicle ownership is not going anywhere. Because how much cheaper would self-driving cars even be than Uber? How much of the cost of the ride sharing is the human driver? About half. The other half is maintenance of the car and fleet and fuel and lots of other things. So it would even make Ubers that are twice as cheap, but Uber tries this. We can already do twice as cheap Uber today. It's called subsidies. And they still, can't get more than a few percent of a lot of these markets. This is US car ownership. This is Chinese car ownership. Huge potential market. Car ownership will continue for a long time. Like, we're not going to rethink and revolutionize the way that we have cars. People like owning cars for the same reason people like owning houses. So if people are going to continue to buy cars, what does a better car look like? You think of cell phones. You go back. People had cell phones in the early 2000s, but no one really had smartphones. So what does, and this is a Benedict Evans quote, right? What does a smartphone on wheels look like?
Question down front on your right. Would this change if it was mixed use, in the sense of, if you want to get on an interstate, it will only be with a driverless car, so you flip a switch or something, and then when you get off, it goes back to human driving?
Well, so yeah, I mean, you can build that. We're already seeing systems like that today with Tesla Autopilot. We're seeing systems where they still require monitoring, but they can do a lot of the work on the interstate, and I do think this is the direction that we are headed. When it comes to we're going to rezone interstates as autonomous vehicle-only zones, some legislature person can talk about that kind of stuff, but in reality, there's no reason to do it. Yeah, maybe you have, this is the autonomous lane, kind of like the HOV lane. I could see that happening. But does that answer your question? So, on a lot of new cars today, in fact, it's becoming standard on a lot of manufacturers, you're starting to see driver assistance technology. So don't view autonomous vehicles as a binary, like there's either a human driver or there's no human driver. All of those Waymos driving around Chandler, Arizona, still have a human in the driver's seat. That still has to be there to intervene in case the car makes any mistakes. So instead of thinking about it like a cliff, think about it as a gradual increase to full autonomy. So we had cruise control. Cruise control came out in the first cars were in the 70s. It's automatic gas. So when you're on the highway, instead of having to keep your foot on the gas pedal, you press the button, and the car will handle the gas for you. Not so great if there's another car in the way, because it will slam right into that car if you set the cruise control at 65. So that's why we have adaptive cruise control. How many people have cars with adaptive cruise control? Cool, a lot of you. Yeah, it's common and it's nice. The car will do the brake for you and will keep you a safe following distance from the car in front of you. And then lane centering. As distinct from lane keeping assist, which will correct you if you're drifting out of the lane centering actively keeps you in the lane. How many people have a car with lane centering? Okay, less. So if you guys didn't see the hands, it's about 50% of you with adaptive cruise control and about 20% with lane centering. All of these combined, gas, brake, and steering, that's all of driving. A lot of manufacturers were selling their cruise control systems and their adaptive cruise control systems and the lane keep assist systems, and they're all kind of on separate pages if you've ever tried to navigate the OEM's website. I think Tesla did a great job with the branding on this when they came out with Tesla Autopilot. Tesla Autopilot is just these same features, but packaged into one nice, it's Tesla Autopilot. Okay, cool. What is Autopilot? Oh, it drives the car for you. Well, that's not really what Autopilot on the plane does. But interesting PR around it. They know how to be provocative. So this is a Paul Graham tweet. The Tesla Model S was like the iPhone, and that all the manufacturers now have to copy it. The difference is many don't realize it yet. So when these things come out, even BlackBerry is scared. There's initial articles about, the iPhone will never take off because people want a physical keyboard. BlackBerry doesn't think this. BlackBerry starts working, if you guys remember the BlackBerry Storm. They tried. They tried to stay around, but they didn't. I spoke with someone, I believe it was from Mitsubishi, and they said, there's no way that we can now build electric cars because Tesla is so far ahead on the battery technology. They have a 5-year lead on the battery technology. There's no supplier you can go to buy Tesla's battery from. But even if you built a car with the same range, and specs as a Tesla, nobody would buy it because they're also 5 years ahead in a huge number of other areas, like the operating system, like the supercharger network. So I don't know what's going to happen with it with the car industry, but this is kind of where we come in. I was approached by a friend to build the vision system for Tesla Autopilot before it launched. Tesla was using a Mobileye chip. So Mobileye is really the original ADAS company, and I've come to respect them a lot more throughout this journey because they've been saying a lot of this self-driving car is a scam stuff for a long time. And they were acquired for $15 billion by Intel. Not a bad price. Sorry, Intel bought them. Name an Intel acquisition that's gone on to be a successful company. You get bought by Facebook, you're successful. You get bought by Intel, you're dead. Facebook, everything though. WhatsApp, Instagram, Oculus. Oculus Go sold 1 million of those things. I met with Elon a few times. We talked about a deal for building the vision system, but eventually the deal kind of fell through. I'll chalk it up to a miscommunication. But I come up with this idea for a company. Okay, build better Tesla Autopilot, sell to automakers, be rich. This was the pitch that I gave. Well, this was the pitch that I gave to VCs. And it sounds like a good pitch. I talked about the smartphone stuff, and I'm like, look, I mean, Tesla's running iOS. We're going to build the Android. So we did step one. It's called OpenPilot. OpenPilot, I have a little explainer video made by one of our community members after this, but it's effectively autopilot for cars people actually have. So this is a little explainer.
What is OpenPilot? OpenPilot is an advanced driver assistance system that turns your car's lane keep assist function from this to this, as well as provides smoother and safer radar adaptive cruise control. OpenPilot allows you to be driving hands-free and feet-free for long periods of time without intervention, even more so on interstates and highways. Everything is controlled by OpenPilot, but it's easy to intervene at any time. But how does this all work? You need 3 pieces of hardware all bought from comma.ai/shop. First, the giraffe. This device converts your car's lane keep assist camera connector into a more universal port for the next piece of hardware, which is the gray panda. The panda receives information from your car and can also send information as well. This is what sends the car commands such as speed up, slow down, and turn the wheel in either direction. It also has a high-precision GPS antenna used to create HD maps as you drive. Finally, the Eon. This is the main device that drives your car. First plugged into the panda, then mounted on your windshield. It sees your car's existing radar information, which shows exactly how far away the car in front of you is. With this, it instructs the car to speed up and slow down as needed. It also has a high-quality camera that looks for lane lines in the road and tells the wheel to stay exactly centered in the lane lines at all times. As an added bonus, it is also a fantastic dashcam with free unlimited cloud storage. OpenPilot runs on Hondas, Toyotas, Acuras, Lexus, GM, and Hyundais, with even more car support being worked on every day. And the best part? Altogether, this setup costs less than $1,000. Check if your existing car is compatible. Then go buy an Eon, Panda, and Giraffe today and upgrade your car to the future.
That's our slogan. So, back to the business plan, build better Tesla Autopilot. Well, I realize that you're not really going to build better Tesla Autopilot because Tesla Autopilot is not a fixed target. It's much better right now than Tesla Autopilot when it came out. Is it better than Tesla Autopilot now? No, because Tesla has good engineers. When I saw what Tesla was doing with Autopilot, like when I compare myself to the way that like Toyota and auto manufacturers and even the tier ones, Delphi and Bosch, are thinking about this, they're thinking in old ways. They're coding in, well, we have to code everything in MISRA C and run it on 32-bit Freescale tri-core microprocessors that have ASIL-D safety ratings. And this doesn't really make sense. You're not going to get functional safety. You're not going to be able to get a safety spec of these things because there's no formal definition of a car. You're just going to have to use statistical safety. You're not going to want to code all of this in this very restricted C because you're never going to get any sort of modern performance. You're never going to get all the niceties. OpenPilot's coded in Python, by the way. You're never going to get, you're not going to be able to be competitive. Tesla Autopilot is coded in C++, but it's a very nice, high-end, abstracted C++, not the kind of low-end stuff that the car manufacturers are doing. So Tesla's using neural networks, they're using GPUs, we're using neural networks, we're using GPUs. We're using all the same tricks. So we're not actually going to pass Autopilot, we're going to kind of tie it. So we do this, right? And I had thought that the reason that other cars didn't have Autopilot was that the car manufacturers did not know how to build it. This is not true. So I met with the car makers. I met with several CEOs, drove down to their offices. I met with a lot of business development people. I'm still kind of confused about what business development is. I was appalled. You couldn't talk to these people. There is no, I guess it makes sense when you think about it. Ford is a 400,000 person organization. Who is Ford? If I had mind control over the CEO of Ford, I still couldn't make this stuff ship. It's like a big boat. And no one's really steering. Everyone's got like a little paddle, right?
Can I ask a question on your right in the back?
Yeah.
So I think I'm your worst nightmare because I'm both a business development person and a PhD in psychology and not from the tech. So if you're appalled now, you should be a little worried. My question, listening to the way you're thinking about going at the problem and what you're trying to solve, makes me think back to your slide with that big red X on it.
Yeah.
And then the way I shorthanded what you did was you put a big red X through the category or the topics having to do with the ethics and the interaction between the technology you're working on and people. And I know the baby case could be put off as an edge case. I taught probability, I get it.
Yeah.
But that's a placeholder for a whole bunch of issues that aren't about whether Python is going to cut it for me or not. And so I'm wondering how you think about that as you develop your technology. I mean, I understand big companies and challenges moving through, but I think there's a pretty fundamental one when we're looking at some of this stuff around assisted driving, autonomous driving, whatever part of it you think you want to address.
So when it comes to, what I put an X through was people talking specifically about the ethics of autonomous vehicles. The handoff problem is absolutely real. The problem of making sure, just from like an HCI perspective, understanding whether the human is in control of the car, whether the machine is in control of the car, making sure expectations are correct. Oh, these things are extremely important. I don't go into it in this slide deck, but we have some Medium posts about it. We have a camera facing the driver. And we make sure that the driver is paying attention at all times that we expect them to be paying attention. We make sure our transition system, how we alert, how we do the handoffs, has been praised by a bunch of people. Automakers, it like beeps and flashes like a little icon that you have no idea what it means. We have consistent messaging about whether the car's capable of doing this, whether it's capable of engaging here. So I think things like that are extremely important. What I don't think is important is the kind of people who give far-reaching, 20 years from now, we're going to rethink cities around autonomous vehicles. Are we? What's the difference between an autonomous vehicle and a non-autonomous vehicle? At most, it's cost. In these cases, it's also building a product that is more convenient for a user, but from an external perspective, the car looks identical. You can't tell if you see a Tesla on the highway whether that car's on autopilot or not on autopilot. So I don't mean to group those two things together. I think one is extremely important. I think one is people self-promoting and stuff that like I don't see the relevance of. But does that answer? Cool. So yeah, you try to work with these automakers, and you can't. It's a structural problem. Mobileye has more business development people than they do R&D engineers. That's why their tech's not that great, but it's in all the cars. So Yeah, I mean, to go back to the Paul Graham tweet, they don't realize it. The car manufacturers don't realize, when you get in some of these cars and you use their adaptive cruise control, the quality varies wildly from manufacturer to manufacturer. It's almost like these people have never gotten in a Tesla and tried it. So yeah, what do you do? So it's just hard. It's hard at the beginning of the company. This was like my plan. I'm going to sell to these people. I'm going to talk with them. They're going to be reasonable. It doesn't really work. So I realized that who really cares? If Tesla is the iPhone, we just have to build the Android. And the phones already exist. It's not like we have to get manufacturer buy-in. We just have to get manufacturer compatibility. I would much rather work with the product than the company. OpenPilot already supports this whole list of cars. You can go right now, and you can put OpenPilot in these cars, and it will take over the steering, the gas, and the brakes, and it will do a significantly better job than the manufacturer system in all of those cars. OpenPilot is the Android, and just like Android, it's open source. Why make it open source? Well, nobody has any excuse anymore. You've seen it in the last 2 years. How many companies try to raise money off of a demo video of self-driving? Nobody. Because if you can't build something better than what's available in open source and marketed a bit, nobody knows that Stanford code's open source, you have nothing. Right? There is no reason for somebody now to start from scratch on this stuff. Just take OpenPilot, modify it, build it, extend it, and hopefully upstream your stuff. Change the conversation from intellectual property and business development deals and exclusivity to do a pull request on OpenPilot. We'll upstream it. It's everybody's. MIT license. So somebody else could take this, rebrand it, call it their own. Great. I just want to see this stuff be better.
I have a question.
Yeah.
What about safety? Have you tested OpenPilot in all of those vehicles that you had previously? You have.
So not personally, but so we have a safety model. I can go into after I run through the slide deck. I can go to the website and show what our safety model is. So our safety model involves it's two things. It's one, make sure that the system can never do anything quickly. Make sure it can never like jerk the wheel or slam on the brakes or do something faster than a driver could react. And two, make sure the driver is paying attention at all times. And as soon as they touch either the gas or the brake, the car immediately reverts to manual mode. So as long as you ensure those two things, you have a pretty good level 2 safety model. And yeah, be explicit about this. So we say like, it cannot do anything bad within 1 second. So as long as you're paying attention, just reach out. And it's not like it'll ever like turn the wheel like this. It's really designed for highway driving kind of stuff. So if you just reach out, put a little bit of pressure on the steering wheel, it'll just stop doing anything. Making sure this stuff is well done. And also the safety code is not in Python. The safety code is in C. The safety code is on an ASLB microcontroller. The stuff that's in Python is like the machine learning model part of things, which you're never going to be able to formally validate anyway. The safety code is formally validated. It has tests. It has. You got to do this stuff correctly.
Hi, I'm Ashley McCorkle from Intel.
Sure.
And just to let you know, we haven't killed Mobileye yet.
Good.
And we're trying really hard not to. That was kind of an expensive acquisition. You actually have a lot in common in your approach and Amnon's approach with Mobileye.
Yeah.
And one is trying to scale up from ADAS into more sophisticated levels of autonomous driving, I think. The other is assuming that this will never work if you have to put multiple Xeon supercomputing resources in a car. Mm-hmm. He's trying to scale it up from basically like an SoC, like a very light computing, and add only thousands rather than tens of thousands of dollars to the price of a car, right? Yeah. So one of his assumptions, though, and I think is relevant for the lead up that we had previously, the warm up on trends in AI, is rather than trying to use a brute force approach, where I think like you were saying, having 3D LiDAR mapping of the entire terrain and having these massive crunching to be able to map, in 3D, the entire surroundings of the car, using a very light compute method that is really based not on, these deep learning based number crunching, but on a rules based approach. And I think he's also published that as, basically open source, this responsibility sensitive safety, where you're programming a set of rules into the AI that basically encapsulate what society's idea of safe driving is. And by society, it can be a little bit flexible as well. Like an Israeli car can drive differently than a French car than an American car. So what do you think of that approach? And do you agree with that particular assessment of AI and brute force computation in cars?
So, multi-parts here. I've watched all of his recent talks, especially after Autopilot comes out. I've grown to respect his perspectives a lot more. He gave a very good CVPR talk where he went into actually like what it takes to make these computer vision things reliable enough to drive cars. I thought the formalization of that stuff, he goes into one where he talks about like formally specifying what it means to be a safe driver. I thought that stuff was pretty weak. The problem is what he's really trying to do there, the subtext is we want to make sure we are never liable for any accidents we cause. I mean, you can view the world that way. That's how like lawyers and accountants view the world. I don't. I want to figure, I'm an engineer. I want to drive accidents down to zero. Let's root cause it. Let's figure it out. NTSB, not NISTA. So I also don't think it really works from a technical perspective, because take a double yellow line. The rules of driving say you cannot cross a double yellow line. But if you do not cross double yellow lines and you're driving around San Francisco, you will never get anywhere. There's an Uber with their blinkers on right there. Okay, so then when is it okay? Do we formalize this, or do we look at big data? My argument is that the definition of driving is what people do when they drive. Now, you say not everybody's a safe driver. This is the Anna Karenina quote. Every good driver is good in the same way. Every bad driver is bad in a different way. Because of that, the statistical algorithm, the deep learning algorithms, kind of ignore the bad data because they can't find much signal in it. Instead of thinking of the average driver, think of a committee driver. Think of 100 people sitting in a room voting 100 times a second on what the car should do. Some of them may be drunk, some of them may be distracted, and some of them may be asleep, but the committee will probably still make the correct decision. So I think that's more the approach, and when you try to formalize this stuff, even trying to formalize what a car is becomes extremely hard. So I don't know. I don't think it's gonna go anywhere. I think the way to actually do this is with big data and statistics. Does that answer the question?
Question over here.
Sort of. Yeah.
Yeah, I work for a big insurance company, so
Sure.
I'm curious, in your safety stats when you talk about it, and if you're going to cover it, great. I can't find any data as to when openpilot actually came about, so I'm curious how long it's existed.
Yep.
And then two, when it's been in an accident, how is fault determined,
Yep.
and how is that dealt with?
So I have some stats on a later slide, but it's a dash cam as well. So we've had no at-fault accidents so far with the system engaged, which is better than the average. Well, you'll see how many miles we have. But how is fault determined? I mean, the exact same way it's determined. The human is still legally in control of the car. OpenPilot is a level 2 system. So just like Tesla Autopilot, or just like imagine you put your car on cruise control, right? You can't say, well, I understand I rear-ended you, but the car was on cruise control and it wasn't supposed to. Great, you're liable. So liability is determined in the exact same way that an accident between two humans would be determined, right? In fact, people think that the problem with these kind of systems is you can't introspect and ask them. You can't say, why did you make that decision? You can't ask humans either. If you go after a car accident and ask humans what happened, their recall is extremely bad. If you have dash cam footage from both cars, now you start to figure out what happened. So I think devices like this, which also function as cloud dash cams, will be an extreme boon to the insurance industry. Here you go right away, instant fault. I like insurance. I like the whole business is, well, the whole business is great. It's statistics. It's we're going to drive down accidents and we're going to charge and we're going to make our profit, and it's great. So yeah, how is fault determined? In the exact same way it is with humans. So yeah, OpenPilot is not it's not some. Oh.
Hi, so I'm a human machine teaming engineer. So you talked earlier about automation as a gradual rise rather than as a cliff. There's a lot of work on levels of automation like you were talking about. Do you expect OpenPilot to eventually climb that gentle slope to full automation? And if so, what do you expect to need to change or grow in capabilities to achieve that? If not, why not?
Yes, I do. So we're going to need a few more. Okay, right now it only has one forward-facing camera. That's clearly not enough. You'll need 360 degrees of vision. I think you'll need a bit more compute than what you currently have. If you really want to say the human doesn't have to pay attention, you'll need to talk about like systems reliability engineering. You'll need to put 2 processors and making sure that failure cases are not just, right now a lot of failure cases we have, our safety model is based around having a human driver in the driver's seat. So as long as we don't kind of have false positives, it's okay, but you start to get into true negatives becoming really bad as well. If you're trying to remove the human from the system. So do we eventually get there? Yeah. When are we ready for it? When the statistics show we are. When we start to see in the statistics, oh wow, OpenPilot has driven this stretch of road 1 million times and has never made a mistake. Is that good enough? Figure out the statistics and see, maybe. Does that answer the question?
Yeah, but kind of an add-on question.
Sure.
So you were talking earlier as well about restrictions in the utility of full automation in terms of the larger system that the car is driving in. What are your thoughts about that going forward? That just the ecosystem of consumer desires will change and legislation will follow, or what? And design of traffic systems.
Yeah, it'll be gradual. It'll be what makes sense. I don't know. I don't think it's going to change that much because I don't think machines and humans are that different. I think that the things that have been developed over hundreds of years for human drivers will actually work out to be, those things are actually pretty useful for machine drivers too. You're like, well, machines won't need stop signs. Oh, I forgot about that whole scam, V2V communication. Oh, machines won't need stop signs. The 2 cars will just communicate with each other. This is horrific. I don't know if anybody knows anything about safety who comes up with ideas like this, because now you need 2 active components to work correctly for a stop sign to work. The beauty of stop signs is it decentralizes the logic. Either party, there would be so many more accidents on the road today if every driver wasn't actively avoiding accidents. Think about every time you hear a horn honk. That's an accident that would have happened if I didn't actively swerve. You need both parties to be paying attention. So yeah, with respect to like changing these things radically, I don't know. I think that what's good for humans will mostly be good for machines as well. Some things are already becoming less relevant, like road signs, since everybody has nav. Like signs saying, oh, this exit here, okay. So yeah, OpenPilot is not some fancy research stuff. This was actually my drive to the conference.
Hey guys, I'm on my way to the conference. OpenPilot's driving right now. It's got the wheel, it's got the gas and the brake, and it's got the bridge traffic.
I have the car in the parking lot, maybe, if someone wants to go for a drive later.
On your left in the back. So I noticed there's no rear view mirror installed there anymore.
So we don't encourage people to do that. You do not have to remove your rear view mirror for driving, but this is still a road legal car. So the law in California is you need to have 2 mirrors on your car that can see the back. If you have 2 side mirrors, you don't actually legally need a rear view mirror. That's more of just an aesthetic taste on my part. But we do not encourage people to do that, and the kit does not require it. because that would violate FMVSS. But you can do it personally. It doesn't violate anything. So yeah, our business model is simple, profit off hardware. I mean, it's a business model I can respect. We make the hardware for less than we sell it for. We don't license IP.
I was curious.
Yeah.
On the website, you buy these 3 components separately. I think it was $650, something like that. Don't you need all 3?
You do. So yeah, it's about $650 for all of them. Yeah, should we make this easier? Yeah, we should make it easier. I don't know. I'm the head of research now. I used to be CEO. I'm not anymore. We'll get a real CEO who knows things about execution and business. No, we got a new CEO. He's great. Yeah. So just OpenPilot stats. We've driven 8.5 million miles. So yeah, to not have seen a system cause accident in 8.5 million miles, I think it's pretty good. We've seen a bunch of accidents with the system engaged. There's one that's particularly hilarious. The system comes to a stop behind a car, but the car overshot the stop line, and the driver just puts it in reverse and just rams right into him. Good thing he had the dash cam footage, right? So for some comparison, Waymo just reached 10 million miles, and Cruise probably has about 1 million, so we have significantly more than them. The one that I did not put there is Tesla, which has billions of miles.
On your left and the back again real quick, over what time span is this?
This is over, so OpenPilot's been around now for almost 3 years. So this is the lifetime of the system.
This question will be shorter. When you have a deep learning based approach,
yep.
And it's really a game of getting a bunch of training data. So at what competitive disadvantage does that put a smaller company like yourself? I mean, thinking back to your Tesla example, right?
Yeah.
Vis-a-vis, say, Waymo or Tesla, which are just going to be piling on the training miles.
We train our models on only about 100,000 miles of data. The models are not even trained on all the data, and we have almost the same number of miles as Waymo.
So to pull out my Amnon
well, we don't have as many as Mobileye.
Set of arguments, right?
Mobileye has the most, but they're not. We send all the video back.
He would say that if you're trying to specifically avoid crash situations, that it's a very low probability event.
Yep.
So therefore, you would need billions of miles.
I agree.
In order to properly train the system against these sorts of events. And also, every time you update the system, you need another billions of miles in order to retrain the model to avoid these events. So is deep learning really a scalable approach, particularly for a small company?
Yes. So the former part of that, about needing billions of miles to get to level 4, I completely agree. If 1 billion miles is 10 fatalities, maybe 5 fatalities, you have to have that kind of stuff in your data set if you're trying to say that your system's level 4. Do you need to gather a new billion miles? No, you need some good statistical way to show that your system can function on replays. So we can just rerun the new system over the billions of miles and say it's still good. Does deep learning scale? Yes. You have to start to you're not going to train on all billion miles, and you don't have to. When you want to deal with crash scenarios, we're going to have like a data set where it's like, here's 1 million near crash scenarios. These are the good ones. This is what you should do. We can do automatic recovery on that stuff too.
Okay.
So I got 2 minutes. Let me just get through the last few slides here. This is daily miles driven. And this is daily percent of miles engaged. More than 50% of the miles are being driven by the system. And this is crushing Tesla. Tesla's about 30. The reason ours is significantly higher is because we don't disengage on the steering wheel, and everything is just more gradual and gentle. We view it as much more of an assist system than an autopilot. But our goal is to get that number up to 100. So it's kind of growing over time. We got some new users who are less power users. It's also engaged less around the winter because there's snow on the roads. So we expect to see a hump in the middle of every year. But yeah, so how to scale and win. We already have a product people pay for and use daily. Continue to improve driving quality and car support. Lower the barrier to entry. You don't have to buy 3 weird animal named things. And then partner with dealerships for mass distribution. Don't try to talk to the OEMs. I think it's hopeless. if you partner with dealerships, it's like partnering with you got your phone in the AT&T store and the T-Mobile store. I've talked with some dealerships. They're super hungry for this kind of stuff, and they're the kind of people who you can talk to. You're like, look, we make this thing. We sell it to you for $600. You sell it to people for $2,000. You get $1,400. That's a good deal. So if you're interested, we're on Twitter, comma.ai, follow me on Instagram, George Hotz, and that's the talk.
One on your back and your left, please.
All right. There was a question over here first, and then we'll come back. The gentleman with this green
Yes,
shirt.
so how do you deal with, and you answered it a little bit, or at least hinted at it because of the winter comment. All the sensors on these cars are in different places. They have different limitations or blind spots. How do you deal with the fact that your 100,000 miles of training data probably doesn't accommodate degraded conditions, and so how do you build models and understand how they vary in these degraded capacities? Because your system, I understand that the human's always engaged,
Yeah.
but at the same time, the AI is going to be generating some faulty data, and how do you detect that?
Yeah, it's not generating faulty data, and we do have a huge diversity of weather conditions and locations in our data set. The data set just comes from all the users. So we have whatever the users are actually driving on. So that's not really that big of a problem. When it comes to the sensors being different, this is why we have the Eon. The Eon has a camera on the back of it. That camera is the same across all the cars. The radars are similar enough, and the actuators are similar enough that we've built a hardware abstraction layer that abstracts them to this uniform API that gives it to all cars. I can go in a lot more into technical details of that. But yeah, so again, it's level 2. If the car traction control fires, if the ESC fires, we disengage. We're like, you got to be driving right now. Just like you should not use cruise control in the snow, you should not use these systems. If there's snow on the road. If there's snow on the side of the road, yes, sure, it's fine.
Robert, did you still have a question?
My question was around, you mentioned the cloud storage of the dash cam video. Is that a subscription model, or how does that work?
Right now it's free, but we're moving towards, yeah, we're looking into that kind of stuff. It's expensive. Storage is expensive.
Okay. Z, and then we'll pop back over the side.
You're tracking all the location data. How do you manage the privacy around that?
By using our system, you consent to giving us full access to all the data. If you're not okay with that, don't use it. I'm very open about that. I'm not like Facebook. I'm not wishy-washy. You are giving us all the data, and we will use it for whatever we want. If you're not okay with that, don't use the system.
Far right side.
So I have 2 quick questions. One is, have you found any issues with contextualizing how people drive in different regions? I know in Buenos Aires, for example, as soon as you see a yellow on the other direction, you start going. In DC, where I'm from, you kind of let reds run out. I always imagine taking half DC drivers and half Buenos Aires drivers and watching what would happen. So when you have these votings, you have these different conventions. The other one is are you looking at the attention data as people are going more confident in the system? Are they more willing or more likely to pull out their phone or start losing their attention because they don't have to? Again, here we're starting to get in a situation where people are feeling pretty safe on the highway and they're not paying attention anymore.
This is why, after the second Tesla accident where the guy hit the guardrail, we're like, we have to ship driver monitoring immediately. So right now, if you're driving and you look at your phone, if you look at your phone for more than 4 seconds, it will beep. And then it will continue to steer, but it will stop gas. It will stop doing the gas. So if you are distracted, it won't accelerate anymore. And then people learn eventually. If this becomes a problem, we're also going to put in lockouts, but that hasn't really become a problem yet. Tesla should do driver monitoring as well. So yeah, as people become more confident, I mean, that's the danger. As these things get better, people pay attention less. And you just solve it with driver monitoring. Make sure the driver actually pays attention and punish them for not.
And then the contextualization of regions.
Oh, regionalization. So we just have a country filter right now. Most of the data comes from America. It works the best in America. Driving is similar enough in America. You will get into weird edge cases, maybe like the Pittsburgh left. I think the way to solve that problem long term is to train different models for different regions. It's like the iPhone has different stuff. You just load in the region model.
Okay, maybe time for one more.
Do you have any
Where is
thoughts
that
on the
coming
security
from?
aspect of it?
Sorry, could you raise your hand wherever you are? Oh, right in the middle.
Yeah, security aspect against hacking for OpenPilot.
So car hacking is one of these things that also people make a ton of money talking about in conferences. Can you give me an example of when it actually happened?
But at least you have seen situations where people have, had a regular laptop or something talking to the canvas.
Oh yeah, I've seen Charlie Miller do a PR stunt, but I've never seen, car hacking does not appear to be an actual threat by malicious actors in the real world. When it does, I'll consider it much more seriously, but like until it does, like what are people really going to do? They're not, it's not really a thing. But use industry standard security, don't do stupid things.
Speaking from experience though, if you want to sell your system in certain countries like China,
yeah. We've given up on that market.
Yeah, they have a lot of restrictions, and they actually want to be able to monitor the AI because they're very paranoid about cybersecurity.
Our stuff gets into China through GitHub. I'm not touching that market. I'm not working with no people like that.
Okay, well, I personally think this was a great way to start the conference. Because this is one of those... This is a talk where I'm like, 1 minute, I'm like, yeah, I'm really on board with that. And then the next, no, I hate what you just said. And then the next minute, I'm like, yeah, I really, and then I'm back to... talk about a provoking way to start the conference. George, thanks very much for being with us.